All right, so this is Chapter 7, Section 5, Exponential and Logarithmic Equations. Our learning objective is to solve exponential and logarithmic equations. And just so that you have this as your frame of reference, if we are going to be using the properties of logarithms and the change of base formula. So if you don't have those at the handy, like with your notes from previous, you definitely want to get those out when you do this assignment so that you're not trying to guess what the properties of logarithms are. Never guess, just go ahead and look it up. But having them in these notes will help save you time. Any equation that contains the form b to the cx, such as a equals b to the cx, where the exponent includes a variable. Exponent includes a variable. That's called an exponential equation. We are going to use logarithms to solve exponential equations because, believe it or not, we've made it this far in our math career without ever solving an exponential equation. So we're going to take a look at this problem. What is the solution of 27 to the 3x equals 81? So the first thing we're going to do is rewrite the terms with a common base. We've been doing exponents enough now where I'm hoping that you're weaning yourself off of that perfect square, perfect cube, perfect fourth, perfect fifth power chart, and you can now are starting to identify these perfect values. 27 is 3 to the third power. 81 is 3 to the fourth power. The power property of exponents says if I raise, it's right here, a power, it's not right here, but this is the power property of logs. The power property of exponent says if I raise a power to another power, I multiply the exponents together. So I'm going to go 3 to the 3 times 3x. 3 times 3x is 9x equals 3 to the fourth. If two numbers with the same base are equal, then their exponents are equal. So now I'm just looking at 9x equaling 4. If 3 to the 9x equals 3 to the 4th, then 9x equals 4. So now I get to solve and simplify. Divide both sides by 9. X equals 4/9. All right, when bases are not the same, you can solve an exponential equation by taking the logarithm of each side. If m and n are positive and m equals n, then the log of m equals the log of n. So we're going to start with 5 to the 2x equals 130. We're going to take the logarithm of each side. So I'm going to go log 5 to the 2x equals log 130. We're then going to use the power property of logarithms that says if I have a power inside my logarithm, I can write it as a coefficient on the front. So I'm going to take this 2x and I'm going to move him out front using the power property of logarithms. So 2x log 5 equals log of 130. We're going to divide each side by 2 log 5 to isolate x. If I divide by 2 log 5, then the 2 divided by 2 is 1. Log 5 divided by log 5 is also 1. And I'm left with just the x equaling log 130 over 2 log 5. I know this may seem ridiculous, but I'm going to ask you to go ahead and get out your calculator and attempt to use your calculator to solve this. If you are not getting the same answer that we get here, then there's an error in the way you're using your calculator, and we need to fix that now because you don't want to get this wrong because of a technical error when you know the concept. So when I do these, I'm going to go ahead and do my numerator, press equals, and then divide it by parentheses my denominator. So I'm going to go 130 log, click, divided by parenthesis 2 times log 5. Those parentheses equals 1.5122. We're going to be solving an exponential equation with a graph. This one says graph or table. I'm going to go ahead and just use the graph because you can always click on table and find that answer using the same item. So the first thing I'm going to do, you want to make sure the first part you graph is this one, y equals 7 to the 4x, and then we're also going to graph y equals 800. So you graph the left-hand side of the equation, y equals 7 to the 4x, and you graph y equals 800. And then I changed my settings so that I could see my y's near the 800 region. And you get, where they cross, you get x is equal to 0.859. So the answer is 0.859. X is equal to 0.859. We're going to do the same thing with our other equation. We're going to go y equals 5.2 to the 3x and y equals 400. So when you graph y equals 5.2 to the 3x and y equals 400, they intersect at x equals 1.211. And so the answer is x equals 1.211. I know there's a y value there. We are not using it in the answer. If you throw down a comma 400, you're telling me that you think 400 is also an answer, and then I have to mark it incorrect, and it's sad Panda Day. All right, so let's look at how this plays out in a word problem form. Resource management. Wood is a sustainable, renewable natural resource when you manage forests properly. Your lumber company has 1.2 million trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half the trees? We know the number of trees and we know the rate of decay. Number of years it takes to, we need to know the number of years it takes to harvest 600,000 trees. And we're going to write an exponential equation and then use logarithms to solve. So we're going to use the decay formula. Since we're harvesting a fixed percentage each year, it works out that we can use an exponential model. We're going to let n be the number of years it takes to harvest half the trees. What? T of n is the number of trees remaining after n years. So a reasonable model would be T of n equals a times b to the n. If T of n is equal to 600,000, that's half the trees, our initial amount A is 1,200,000. Our rate of decay is 7%. So because we're decaying, we are decreasing by 7%. So our B value is 1 plus the rate, which is 1 minus 0.07, or 0.93. I think of it like this. Your rate, your decay value, your B, should be what you're left with after you eliminate your 7%. So if I'm getting rid of 7%, I'm left with 93%. So we get 1,200,000 times 0.93 to the n power equals 600,000. Solve the equation and use logarithms. I'll do it one by one so you can see. Okay, so we are going to divide both sides by 1,200,000 because we're trying to get the n as stripped down by itself as possible. 600,000 divided by 1,200,000 reduces to 1/2. And then we take the log of both sides because we have an exponent. If I take the log of both sides, then I can pull that n out to the front. So then we get n times the log of 0.93 equals the log of 0.5. I divide both sides by 0.93 to solve for n. And then we use our calculator to find out that n is approximately equal to 9.5 years. Then I state it in a sentence. Every word problem should be properly concluded with a sentence that explains what the answer means, like you would do on your portfolio. It will take about 9.55 years to harvest half of the original trees. Okay, so how many years will you have harvested half of the trees if we harvest 5% instead of 7% yearly? So let's go ahead and change our equation. So instead of being here at 7%, we're going to change it to 5. So instead of 0.93, we're going to have 0.95. So that's 0.95 and equals 1/2. And we take the log of both sides. I'm going to go ahead and convert this to 0.5 so that I don't have to mess with the fraction. The power property of logarithms say that if I have an exponent inside my log, I can write it as a coefficient out front. And then to get n by itself, I divide both sides by the log of 0.95. And then it's just a nice little chug on my calculator. 0.5 divided by 0.95. 0.5 log divided by 0.95 log equals 13.51 years. So it's approximately.
We're actually in the 0.5 range.
13.51 years. So it will take about 13.5 years to harvest half the trees. Okay, so we're going to take log 3 minus 2x equals -1, and we're going to solve using exponents, and we're going to solve using a graph. So to solve using exponents, what is the base of this logarithm? What is the base? So it is base 10. The problem we have here is that we don't have multiplying or dividing inside the logarithm, so I can't really separate it out using properties of log. We can raise both sides to the base 10. Because base and logarithms, exponents and logarithms are inverse operations, they cancel each other out. So 10 to the log, 3 minus 2x is just 3 minus 2x. And 10 to the negative 1 is 1 over 10. So now I'm going to subtract 3 from both sides. Solve it just like I would. And divide everything by negative 2. Let's deal with this. So 110 minus 3 is the same as 30 tenths. So this is 1 minus 30 tenths is negative 29 tenths. And then I'm dividing that by negative 2. Dividing by a fraction by a number is the same as multiplying by its reciprocal. So negative 29 tenths times negative 1/2 gives me negative 29 20ths. Or, I'm going to go ahead and put that in my calculator. $1.45. We're going to use solve using a graph now, so hopefully we'll get 1.45 out of our graph. I'm going to let y1 equal log 3 minus 2x and y equals negative 1. Go ahead and do this on your graphing utility to make sure that you're inputting logarithms correctly. All right, so when y equals log of 3 minus 2x and y equals negative 1, the two intersect at x equals 1.45. So go ahead and sketch the solution in your notes.
We do that?
Yes, all week. All right. So we got log 6 minus log 3x equals negative 2. We're going to use this property right here, the quotient property. It says if I have the same base, guys, what's the base of this log?
6.
What's the base of this logarithm? It's the same for both. So our quotient property says if I have two logs that are subtracted, I can write them as a single log with division. So I'm going to go ahead and go log 6 over 3x equals negative 2. Then I go ahead, simplify that just for funds. And then I'm going to go ahead and raise both sides to the 10th base because opposite of a log is base 10. The log and the base get rid of each other. They cancel each other out. They're inverse. I get 2 over x equals 1 over 20, or x is equal to 40.